The Earth's core is as hot as the surface of the Sun. That's around 6,000 degrees Celsius, hot enough at normal pressures to melt all known materials, even the one with the highest melting point, tantalum hafnium carbide. Luckily, the total diameter of the Earth is 12,742 kilometers, which means that you're protected from the core's heat by around 6,000 kilometers of rock beneath your feet. So then how do we know how hot it is down there? We could try digging, and the furthest anyone's ever dug down is a project called the Kola Super Deep Borehole in Russia. It started, like many things from the era, as a part of the Cold War race with America. But many other countries have also had a go. In the 60s, America tried drilling into the Pacific Ocean floor. Then, the German Continental Deep Drilling Program overtook them. And as recently as 2007, a Japanese drill ship got the furthest through the ocean floor. But the Russians have still made it the furthest overall. They reached 12 kilometers down. That's deep enough to fit 14 Burj Khalifas end to end, and you still wouldn't be touching the bottom. Pretty impressive. But 10 kilometers down, the temperatures started to get unexpectedly high.
As you dig deeper and deeper and deeper into the crust, it does get hotter.
At 12 kilometers down, the rock was 180 degrees C, and drilling had to stop.
The key thing really is having an engineering infrastructure that can withstand those temperatures and not fail or melt as it gets hotter.
While it's an impressive feat of engineering to get that far down, 12 kilometers isn't even halfway through the Earth's outer layer, the crust. If we're barely able to make a dent in the crust, how do we know how hot it is in the middle? Well, in 2013, scientists measured the way seismic waves from earthquakes travel through the Earth. Think of it like a planet-sized ultrasound. From this data, we know that the Earth's core is actually split into two parts, an outer core of liquid iron and nickel, and a solid inner core at the very centre. Experiments show that the only way this is possible is if the solid inner core is as hot as 6,000 degrees Celsius. That's as hot as the surface of the Sun. And the mind-blowing thing is that the pressure is so intense at the inner core that the solid iron and nickel literally can't change state, even though the temperature is way past iron's boiling point, and you or I might expect it to be a liquid. The big question is, why? How did it get so hot down there?
So our planet was formed about 4.6 billion years ago. And it started off as this kind of homogeneous mass of molten rock, where rock debris and material that was floating around accreted together. And as this mass got larger and larger as it grew, its gravitational force grew as well. Alongside that, there's a lot of radioactive decay happening. We have these metallic elements that are always decaying away, and that creates heat. This process just escalated in these really dramatic proportions.
As the planet got hotter due to the radioactive decay, all of the heavy elements like iron sunk towards the centre, creating even more heat and the hugely hot iron core we still have to this day. This means that the Earth's core is actually younger than the Earth itself, having formed more recently, and its heat is also responsible for life as we know it.
What's really key about our core is that it actually creates a magnetic field. As heat moves from the inner core into the outer core, it's swirling about, it's swishing about. It's this movement that's going on within the outer core from this liquid iron that then creates the magnetic field or the magnetosphere, that which is really important for life on Earth. It protects us from solar radiation, from solar winds and particles, which are really, really harmful to life on Earth.
So we're far enough away from the core that we're not going to spontaneously combust anytime soon. But more than that, this enormously hot core is actually the reason we're all here today.
Knowing this process, this powerhouse, this heart, is underneath our feet every single day, pumping away, it makes you stop and realize, oh my goodness, this planet, it's alive.